Welcome to this lesson on Six Sigma. Upon completion of this lesson, learners will be able to examine the goals and impacts of Six Sigma, assess the reasons for a company to implement a Six Sigma project, and identify the causes of variation in a process. You've likely used the scientific method since grade school or middle school. The scientific method is a systematic approach used by researchers to investigate phenomena, acquire new knowledge, or correct and integrate existing knowledge. It consists of several key steps: asking a question, conducting background research, formulating a hypothesis, testing the hypothesis through experimentation, analyzing the data, drawing conclusions, and communicating the results. Similarly, Six Sigma follows what is known as the DMAIC cycle, which stands for Define, Measure, Analyze, Improve, and Control. Six Sigma can be seen as an application of the scientific method to business and industrial processes, employing new tools and techniques that are applicable across many fields. This lesson will provide an introduction to Six Sigma, discuss the role of variation in processes, and explore the causes of variation within production systems. The goal of any business or company is to be profitable. For a company to be profitable, it must provide a good or service to a customer. To be a competitive business, the customer's expectations must either be met or exceeded. Otherwise, the customer will take their business elsewhere. The competitive nature of the market puts pressure on companies to constantly improve their product or service in order to keep up with customer needs and competing businesses. The implementation of Six Sigma can help a company stay competitive in the market by increasing customer satisfaction and reducing costs. Companies will sometimes manufacture products that are defective or unsatisfactory to the customer. When this happens, the company loses money, time, and customer loyalty, which can ultimately lead to the failure of a business. Six Sigma is an industry-recognized continuous improvement process. It is a set of engineering, statistical, and managerial tools and strategies which improve manufacturing processes by identifying and eliminating the sources of product defects. Six Sigma methods are applied in countless business and industrial situations around the world, which makes labeling Six Sigma with a single definition nearly impossible. Motorola defines Six Sigma on three separate levels: Six Sigma as a metric, as a methodology, and as a management system. When applied properly, Six Sigma can provide companies and businesses with unmatched customer satisfaction and economic return. Regardless of how or where Six Sigma is used, its continued focus is to produce a good that adheres to the voices of the customer. For these reasons, Six Sigma methodology has been one of most well-known approaches to process and quality improvement. Six Sigma is centered on the idea that product defects can be eliminated by minimizing variations caused in the manufacturing process. By first identifying and then reducing these variations in processes, the quality of the final product can be improved. Fundamentally, the goal of Six Sigma is to improve a process so that the number of defective outputs is minimized. The figure on the left here shows the distribution of two processes that have the same mean but have very different variability. Which of these processes do you think has higher variability? Although identifying and eliminating the causes of variation sounds like an easy task, it can require a significant amount of time, money, and research. You might be thinking, what does variation have to do with quality? To answer this, let's first define variation. Variation in a product is the margin between the product's target value and the product's actual value. It's what makes the product bigger or smaller, or heavier or lighter than the goal. Every process has some sort of variation, which in turn causes the product itself to have some variation. This is important because if a product's condition varies too far from the target value, customers will not be satisfied, and the product is deemed defective. The sigma in Six Sigma refers to the symbol commonly used in statistics to represent the measurement of variation from the target value, also called the standard deviation. How does variation come into play? Think about variation this way. A car manufacturer aims to produce fender panels with a consistent gap of 3.5 millimeter plus or minus 0.2 millimeter with the front bumper when fitted to the car body as shown in this image. However, in reality, some panels inevitably turn out slightly larger or smaller than others. This is where variation comes into play. If the gaps between panels vary too much, customers will notice and complain about poor fit and finish. While it's impossible to make every panel absolutely perfect, the key is to keep the variations small enough that differences are imperceptible to the customer, ensuring satisfaction with the overall quality. In this example, the target value is a 3.5 millimeter gap between the fender and adjacent body panels, and variation refers to how much the actual gap dimensions deviate from this target value. The acceptable range of variation is plus or minus 0.2 millimeter, meaning gaps between 3.3 millimeter and 3.7 millimeter are considered satisfactory. By controlling this variation, manufacturers can produce cars that look and feel high quality, with panels that fit together properly and consistently. Specification limits are bounds that represent the farthest a value can be from the target without being considered defective. Specification limits mark the point at which customers refuse to buy the product because it doesn't meet their requirements. For the car fender, the specification limits of the gap might be 0.2 millimeter larger and smaller than the 3.5 millimeter goal. The figure on this slide illustrates two normal distributions with identical means and specification limits. The difference between the two distributions is the variance. The graph on the left shows that a few parts will be produced that do not fall within the specification limits. By narrowing the variation, as seen in the graph on the right, all parts produced are within the specification limits. An objective of Six Sigma is to take the distribution on the left and transform it into the one on the right. By reducing this variation in the product, the defect is eliminated and the problem is solved. Even once the variation in a product has been identified, the more difficult task is finding what factors are causing the variation. In the tile example, possible sources of variation could be the temperature of the kiln, the humidity in the cooling room, or vibrations of the blade used to cut the tile. There are two basic types of variation: common cause variation and special cause variation. Common cause variation is variation that results from factors that are inherently part of the process. Common cause variation is influenced by several process factors that act independently and randomly from one another. It is usually the result of 6 main factors: machines, manpower, material, methods, measurement, and Mother Nature. These factors are known as the 6 M's. Examples of common cause variation are vibrations in the machines and poor working conditions like temperature, noise, and lighting. Special cause variation is variation caused by assignable special events. These events are non-random and not expected. Examples of special cause variation are a machine malfunction or a computer crash. Common cause and special cause variations are sometimes referred to as chance and assignable causes of variation. Six Sigma uses many tools and techniques that identify variation, the type of variation, and the possible factors causing the variation. In summary, Six Sigma is an industry-recognized continuous improvement process that aids in reducing variability in a process or service. Six Sigma is a complete methodology with engineering, statistical, and managerial tools and strategies to improve quality. There are two basic types of variation: common cause variation and special cause variation. Six Sigma can be used to reduce variation in manufacturing processes and improve the overall quality of the company. Thank you.